All right, we got word problems to help you with. Word problems. Before that, though, a cool, amazing dog saves another dog on the highway. Watch this.
In the middle of this busy highway, and a second dog spots him and tries to get over to him. Now, here's the first dog again being hit. He's lying there in the middle of the road, busy time of the highway, and here comes the second dog who grabs him not with his teeth, but actually gets him with his paws around his neck and drags him in the middle of all this traffic off the road to safety, little by little, inch by inch. Finally, some workers spot the dogs and come over and help them. And by the way, the injured dog lived.
Best friend a hero. That's amazing. That's amazing. So that's pretty amazing, right? So pretty amazing. Love dogs. Dogs care more than humans a lot of times, right? Just pure love. Love dogs.
It is a bittersweet
Let me turn that off. I think it's the news. There we go. Okay, awesome. So helping you with word problems. We did number 1, or probably, maybe, together. Number 2, 3, 4, 5. Awesome. Okay, so let's help you out here. So let's look at a few. Some that were recommended were probably the last one, as well as number 8, 9, 10, 11. So let's look at some of the harder ones there. Again, you're using Sohcahtoa. So the formula that you want to memorize, right? What you want to memorize is trig of an angle is equal to something over something. And that's after the drawing. Could be sine or cosine or tangent. Don't forget on this word problems with the trigonometry that we're using Sohcahtoa. Don't forget what each of those represents. So again, sine is equal to opposite over hypotenuse. Remember that? Cosine is equal to adjacent over hypotenuse. And, of course, tangent, if the board lets me do it. There we go. And, of course, tangent is equal to sine over cosine. Good. So that's going to be opposite then over adjacent. Toa, T-O-A, which is opposite over adjacent. So you definitely need to know these. Supposed to be a D there. So I need to know Sohcahtoa to be able to do this assignment, right? Be able to know Sohcahtoa to do this assignment. There we go. Okay. So let's try, let's see. There we go. So maybe number 2, let's see, 8, 9, 11, maybe 8, 2, 8, 11, last one. Okay, so let's try number 2 first. So a clothesline is connected from a window. A clothesline is connected from a window on one building to a window and a building across the alley. The clothesline is 10 yards with an angle of depression 17 degrees. How far apart are the buildings? So we go ahead and draw those two buildings. And we do have an angle of 17 degrees. Awesome. So there's our 17 degrees. And so they want to know how far the building is. We'll call it X. They do tell us the clothesline is 10 yards. So that would be that. That'd be the hypotenuse. Cool. So now we just have our triangle that we're trying to solve for the distance of the buildings, where we have a line of depression of 17 degrees. Cool. So then we want to label the triangle from the angle. So this would be opposite, and this would be hypotenuse, and that's what we're going to use. So then, what is opposite of our hypotenuse? Do you remember? Come on. That's right, SOH, so sine. So we're going to do sine of 17 degrees is equal to opposite x over hypotenuse 10. Beautiful. So make sure your calculator mode is in degrees, first of all, which mine is. It could be in radians, so double check. We don't want to get you a bunch of wrong answers. So double check it's in degrees. Make sure the video is still running. Okay, good. Just double checking. Okay, awesome. So go ahead and put in your calculator. So we're going to solve for x. So we're not going to switch a switcheroozy this time, but we are going to multiply the 10 over to the other side. And then we'll go and plug that in our calculator. So now that we know our calculator is in degrees, we'll do 10 sine of 17 degrees. Nice. So we get 2.92. That's really close together. Really close together. Huh. Interesting. Let's double check this then. 17 degrees. I guess it's yards. Clothesline is 10 yards with an angle of depression of 17 degrees. So building 1, building 2 looks good there. How far apart are the buildings? Yeah, I guess the hypotenuse is the really long part, huh? So that means the buildings are really close together. So I'm guessing that's in England. There's an alley there where the buildings are like almost touching each other. And that's in York. Look it up for extra credit. Email me. So I've been there. It's pretty amazing. It's close to the Orgminster Abbey where the buildings are really close together. Okay, so we got 10 sine 17 degrees. Awesome. And so that is going to be 2.92. So let's round to the nearest tenth because that's what we're used to doing on these problems. So x equals 2.92 or just 2.9. And then don't forget to label the yards. Yards, army yards. Okay, so there's the answer for number 2. Now I will tell you I'm not as a professional in these ones as I have been in the past. This is the first time we're doing this assignment 2020, March 4th. So double check with me in class if I need to fix anything. But that's what I got. So I do have an odd solution that we can look at it in a second. Towards the end. Okay. So then I remember with another class, I remember doing number 9 already. So there's to help you out with number 9, x equals 61.1 yards. But then you still have to do in your calculator 60 over cosine 8 degrees. So this is like a two triangle part where you're on a roller coaster looking down at the Ferris wheel as well as the merry-go-round. And so just one of them you want to call, maybe the bigger one, you want to call 11 degrees. And then the smaller one, maybe 8 degrees or whatever. And then set it up like that. But let's take a look at number 8 now. So 2 boats are observed by a pair of sailors 75 meters above a lake. Okay, so we have a pair of sailor. So we're going to kind of draw that guy there. Yeah, he's like hanging on for dear life. Don't draw me, guys. Ah, don't draw me. Oh, I guess you should give him a little bit of a waist. There we go. And then there's his feet. I don't know. Okay, don't draw me. Okay, so he's parasailing, and which is pretty awesome from some boat over there. And then we have 2 boats are observed by the parasailer, 75 meters above. So he is 75 meters above a lake. The angle of depression are 12.5 and 7 degrees. How far apart are the boats? Wow. Okay, so that means that we're going to have a couple of boats going on there. Let's go ahead and put a boat right here. Look, that's a great picture of a boat. Look, it's a boat because of the way it is. What the? Okay, so we got our 2 boats going on there, on the water. And so we want to know how far apart these boats are. Cool. Call it x. And how we're going to do that is by solving our 2 triangles. So we're going to find this distance, and then also find this distance. And then probably minus the 2, right? Okay, so then the bigger one, distance there, is probably this whole distance. So that's going to be 12.5 degrees. And then we have the smaller distance, just 7 degrees. So 2 different triangles going on here. So let's go ahead and call this y maybe if we want, and solve for y first. Cool. So then with our 7 degrees, opposite, good. And then this is the right angle, and that means this is adjacent. Cool. So we're going to use opposite over adjacent. So let's go ahead and do opposite over adjacent, which is what? Tangent. So we have tangent of 7 degrees is equal to opposite y over adjacent 75. Nice. So then if we go ahead and multiply 75 to the other side, we'll find out what y is. Cool. Okay, so now we'll go ahead and do 75 tangent, opposite over adjacent is tangent, of 7 degrees. So 9.2 meters. So this guy's 9.2 meters. That's that distance, that whole distance. Now we're going to have to do the bigger distance. And so I don't know what to call that. So maybe whatever the difference is, I don't know. So let's just call that question mark. And then we're going to do the whole big triangle now. Maybe call that x. Cool. So then that's going to be 12.5. So now all we're going to do is replace this with 12.5 because it's still x is still opposite. And 75 is still adjacent. It's still using tangent. So now we go back to our calculator. And instead of using 7 degrees, we're going to go ahead and use 12.5. Nice. So we get 16.62. So we'll go and say 16.6. Let me double check. Yep. Okay, so now the whole distance is 16.2. And now if we just want to know how far the boats are apart, we're just going to do 16.2 minus 9.2, right? Minus 9.2. And so I'm hoping, is that 7 meters? 7 meters. So 7 meters, question mark. So we'll call that distance 7. 7 meters. Wow. 7 meters. And that's the distance between the boats because we took 16 minus 9.2. And we got approximately 7. I rounded there. 16. What the? 16.62 new bold, silly. Oh, sorry. So 16.62. Not going to be that easy, new bold. Sorry. Okay, so it's 16.6 minus 9.2. That's going to change their answer. I thought it'd be nice, and that's okay. Okay, so 16.6 minus 9.2. There we go. Gives us 7.4. So we got 7.4 meters is our answer. So that's going to be this distance right here. 7.4 meters between my boats. Cool, so there's number 8 done. Woo! Okay, so number 9 kind of showed you already. We'll look at 11 and maybe the last one. Okay, so number 11, we have Kirk visiting Yellowstone and Old Faithful on a perfect day. Yeah, Kirk. His eyes are 6 feet from the ground. So let's go ahead and draw him. Yeah, what up, Kirk? There's their eyeballs. Smiley face. Okay, so then he's got, that's a great drawing, Newell. Okay, so 6 feet off the ground are his eyes. There we go. 6 feet from the ground. And then the geyser can reach heights ranging from 90 feet to 184 feet. If Kirk stands 200 feet from the geyser, so let's go and draw 200 feet. Yeah, you better, Kirk, else you're going to get all hot water all over you and burn. Okay, and so then we have Old Faithful. Yeah, Old Faithful. So it's a bit of a mound, not too huge. And then you've got kind of a hole in it there that erupts. Okay, so if Kirk stands 200 feet from the geyser and the eruption rises to 175 feet in the air, what is the angle of elevation to the top of the spray? Wow, that's a great question. I don't know if that's... Sorry, just getting carried away there. Okay, so we have 6 feet above the ground there. Awesome. Okay, so then, let's see. So we know that this, from his nose, Pinocchio, really long. We know this is 200 feet. Awesome. And then his eyesight, good. So up to here is what we want to know. So if, let's see, maybe I didn't need to draw the big long nose. Did I need to draw that? I don't know. Why did I need to draw that? If Kirk stands 200 feet from the geyser, eruption rises. Okay, so if Kirk stands 200 feet from the geyser and the eruption rises to 175 feet, so we say this is 175, good. What is the angle of elevation to the top of the spray to the nearest tenth? Okay, so then 175, probably minus 6? No, yeah. So 175 feet, okay. And then, so 175 feet minus, this is not to scale, not to scale. Just saying, because my Kirk is huge. Okay, so 175, that's the whole distance there. And so if we go ahead and take 175 and minus 6, how tall he is, that's going to give us 169 feet. Cool. So now we know the angle we're looking for. So what is the angle of elevation to the top spray near the 10th? His eyes are 6 feet off the ground. The guy should reach this. Cool. Okay, so we're going to go ahead and put a question mark. We want to know this angle. So we want to find that angle. Awesome. So then if that's a triangle, 200 feet and 169 over there, we can find the angle if we know what these are labeled as. So this makes a right angle, right? Right here is our triangle. Should I do it in red? Lady in red, dancing here with me. Okay, so there's our triangle. Nice. So we want to know that angle. Okay. So then to know that angle, you got to label these. So from his eyesight, from the angle, don't know what it is, but this is going to be opposite. Good. And then down here is going to be adjacent, right? Because over here is hypotenuse, which we don't know what it is, so we can't really use it. We could use Pythagorean theorem to find it out, though. But let's just skip that step and just do opposite over adjacent. Okay, so we have opposite over adjacent, which is tangent. Good. Remember that opposite over adjacent is tangent. Ow! My toe! So tangent. And so tangent of some angle, we don't know. Tangent of some angle, some degree, we don't know, equals opposite 169 over 200. That's how we set up our problem. So now we got to figure out what question mark is by getting tangent to the other side. So then how do we get tangent to the other side? We do the opposite of tangent. And the opposite of tangent, to get rid of it to the other side, is inverse tangent. So then question mark is equal to the inverse tangent of 169 over 200. Awesome. Okay, so we plug that in our calculator, and we go inverse tangent of 169 divided by 200. Cool, cool. So then that gives us 40.19 degrees, so 40.2. So that's going to be our angle of elevation. So then we say that our angle is equal to 40.2, rounded to the nearest tenth. 40.2 degrees, rounded to the nearest tenth. That's what question mark equals by inverse tangenting the other side and putting in our calculator. Nice, 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 nice. Last but not least. In the afternoon, Kirk returns and observes the guys are with the... What problem is that one? I don't even remember that one. Huh. Yeah, Kirk. Is that 11? So we're about to look at our non-right triangle problem, which is the last problem. Just had some help getting this on here. What the? 11 continues now. So I'll let you figure out that one now that you tried this one. Kirk returns and observes the guy who's spread returning 23 feet, and his elevation is 37. How far is he from? Cool. So that should be like to reach the height opposite over adjacent again. So use tangent 37. But this time it's 123 over x, and you're gonna have to switch a roozy. Cool. Okay, so now we're looking at number 14. So number 14, you're studying the Gulf of Mexico, and you got this cool triangle going on. What? And we're looking for the area of the triangle, right? Looking for the area of the triangle. Place where planes get lost. Here's the diagram. So the area is equal to 1/2, or 0.5, times the side, times the other side, times the sine of the angle between the sides. So you'll see one of these on the test, and make sure you know how to do area of a non-right triangle. And don't forget to use your different colors for your R's and your T's and your L's. What the? Okay, awesome. So again, it's the area of a triangle is 1/2, or I just like to use 0.5, easier to put in your calculator, times your side, times your other side, times the sine, make sure it's sine, not cosine, make sure it's sine. So make sure it's sine of your angle. But specifically, the angle has to be between the sides. Between, right? Between the sides. Make sure it's side angle side. Make sure it's side angle side, else you cannot get the area correct. Cannot do side side angle or angle angle side. No, no, no. It's got to be side angle side. However, if you do know the length of one side is 950 miles, and the other side is 975 miles, and then the angle between them, there's your key word, is 60 degrees. How big is a Bermuda Triangle? Cool, so you try it first. Pause me. Pause me. Hey, you, behind the screen. Pause me. So go and pause me. You haven't paused me yet. Pause me. Okay, I'll wait. No. You plug it in first. Okay, did you do it? I'm still waiting. Okay, so 950 times 975 times our sine of the angle, 60 degrees. Good. Oh, I got a lot of parentheses going on there. Okay, so that gives us, holy cow, that's a big area. It's a huge area. So let's just double check I typed that in right. Here we go. So there's our sine of 60 degrees. Good. There's our 975 times our 950. Wow. Our Bermuda Triangle area is so big of an area to get lost in, right? Okay, so then our area, how big is the Bermuda Triangle? The area of it. So our area is equal to 401,078. 401,078 points to the nearest tenth is 0.01. So just 0.0 is fine. There we go. And then, oh, don't forget, is this miles? This is miles. That's a huge amount of miles. Wow. That's a huge triangle to get lost in. There we go. Thanks for watching. Peace out, brother, sister. Thanks for watching. Peace out. Thanks for watching. Oh, yeah. Tribute to Katie Randall. You like drawing? You're amazing at drawing. There you go. Tribute to you. This is Simon of Drawing. Bye.